Hello everyone, my name is Rohit Singhal and we were discussing about the topic redox reactions. In the previous lectures, we have discussed briefly about the redox, redox reaction comprised of two words, reduction and oxidation. Then we in deeply discussed that what is oxidation reaction, what is reduction reaction. Then we have discussed the oxidation and reduction reaction in terms of electron transfer process, because we know that the basis of any reaction is the electron transfer reaction. So, we discussed the redox reaction also in on the basis of electron transfer. We told that the oxidation reaction is the loss of electrons and reduction reaction is gain of electrons. We said that when both the reaction, when this is a complete reaction shown, means both the things goes simultaneously, oxidation and reaction, and that whole reaction is called as complete cell reaction. For our simplification, what we do is we divide that complete cell reaction into two equal halves. One half cell corresponds to oxidation and another half cell corresponds to reduction, known as oxidation half cell and reduction half cell respectively. Then what we said that obviously there is no element that will automatically or some lose electrons, it will be needing someone or some driving force to lose electron or to gain electron. So, what we have said is introduce two new terms, one is oxidizing agent and one other is reducing agent. Oxidizing agent, what we said is what the element that is accepting the electron, acceptor of electron. Reducing agent is donor of electron. From the example we have seen is whichever element is getting oxidized is the same element called as reducing agent, because that element is only responsible for the other half cell reaction. Similarly, the element that is getting reduced is responsible for the oxidation half cell, and that is why it is called as oxidizing agent. Remember the term agent. Okay. So, we have discussed oxidation, reduction, oxidizing agent, reducing agent. We have discussed one of the examples, one of the few examples from the NCERT examples only. The last example we were discussing where we left was sodium reacting with hydrogen gas to 2 NaH. Initially what it seems that sodium is gaining electrons, addition of hydrogen. What initially it seems that addition of hydrogen, that means reduction, addition of electropositive, that means oxidation. Okay. Initially it seems like this if we see by the earlier perspective, but now we know about the electron transfer process also. Okay. So, let us try to see this reaction by the electron transfer thing. We see that sodium has a plus 0 charge and here it is plus 1 and minus 1 and hydrogen is also 0. So, what is happening to sodium? Electron transfer. Sodium is getting oxidized to Na plus electron, 2 sodium, 2 electron, and hydrogen is gaining 2 electrons to form 2H minus, right. And we know whatever element loses electrons is called oxidation, and this gain of electron is called reduction. Now, we have an ambiguity in terms of this. I am saying addition of hydrogen, it seems to be like reduction reaction, for hydrogen it seems like oxidation reaction, but in electron transfer when we see it is a different case. Now, what should we do in this case? We know electron transfer thing is the basis and this is correct. Okay. It is not like this is not correct, but there is one catch in this reaction, this is not true, this is wrong and this is right. Why is it so and how to explain this? If we carefully see the reaction, that sodium in sodium there is not having H plus has not been added, actually H minus has been added and H minus, an electronegative element has been added, and electronegative element addition is called oxidation. Okay. So, it is better to see the reactions in terms of electron transfer. So, that there should not be confusion whether there is H plus or H minus, that I have already discussed briefly in the previous class, that see the reaction whether it is an oxidation reaction or reducing species in terms of electron transfer. Okay. So, this is I am saying oxidation half cell and this is reduction half cell. Okay. And this complete is an redox reaction. Okay. So, we can make mistakes while in terms of saying addition of hydrogen or removal of hydrogen or positive element, electronegative element. So, you must stick on the basis of electron transfer. So, for your better understanding, for your better simplification or for your better justification of whether the reaction is getting oxidized, whether the species is getting oxidized or getting reduced. Okay. This example has been cleared. I have discussed briefly into the previous lecture, just to clarify it further I have discussed in this one. Now, there is one thing I have started, let us say there are two elements and both the two elements wants to give the electrons. Okay. There is one acceptor, let us say there is one Cl2, okay, and there is one let us say sodium, or let us say there is magnesium, there is sodium, there is magnesium and there is chlorine. Chlorine is there to accept electrons, right. Now, we will see, we have to see and we want to predict that which element will first get oxidized. There is chlorine to accept electrons, it can accept electrons of both sodium and magnesium, but which element will first go under oxidation, sodium or magnesium, that is called as competitive electron transfer. That comes under the topic competitive electron transfer reaction. Why it is competitive electron transfer reaction? Because there has been a competition. If I am saying sodium is there, magnesium is there and chlorine is there. So, there has been a competition between sodium and magnesium, that which element will get oxidized, which element will transfer its electron first from sodium or magnesium from to what, to chlorine. So, there is a competition between sodium and magnesium. For this let us take one of the examples you have studied or you have maybe done in your practical labs, is we prepare a solution of copper sulphate, okay, copper sulphate aqueous solution. You know copper sulphate aqueous solution, this is an ionic compound. Okay. In aqueous it will dissociate into copper 2 plus ions and sulphate ions, right. So, better I am saying ki copper sulphate is actually copper 2 plus ions. Okay. So, when we react this copper sulphate, a solution of copper sulphate reaction with what, a zinc, when we react this copper sulphate with a zinc strip, this is an aqueous solution, and this will react with the metallic zinc. So, what happens is this copper sulphate normally is in what, blue in color, and what happens after the whatever the reaction forms is the blue color disappears. The blue color disappears. What color does it form then? It forms, okay, the blue color of the solution disappears. Now, why is it so the blue color disappears? What happens is, in presence of this copper sulphate, what happens, this copper sulphate, there is an oxidation of zinc to zinc 2 plus in presence of copper 2 plus ions, and this copper 2 plus ions gets reduced to form copper. Okay. This forms copper, and this goes in aqueous solution, and this zinc sulphate zinc 2 plus can be present in the form of zinc sulphate. Okay. this reaction is also called as displacement reaction. You have studied displacement reaction, you must have studied in class 10th maybe, displacement reaction. Okay. So, now why is it so that copper 2 plus is getting reduced to copper and zinc is getting oxidized? See, zinc getting oxidized and copper 2 plus getting reduced. Okay. So, this is the reaction. If I just want to show the reaction by the ions only, I am not showing the anionic part here. So, the reaction is complete reaction is this. Copper 2 plus reacting with zinc, forming zinc 2 plus copper, and if we want to describe into two half cells, oxidation half cell, that will be zinc giving Zn 2 plus 2 electrons and copper 2 plus gaining 2 electrons to form copper. Okay. Now, this is called as oxidation half cell, we know, and this is reduction half cell. Now, let us do the opposite thing. Till now we have placed a metallic strip of zinc into the copper sulphate solution, zinc metal in copper sulphate solution, right. Now, let us do opposite. Now, let us place copper metal in zinc sulphate solution. Let us try to do this. Okay. Let us do this. If zinc sulphate solution, that means Zn is plus 2 already and we are adding the copper metal. Now, a normal, what you can imagine that copper may form copper 2 plus, Zn 2 plus will form zinc, and now this does not happens. There is no change of color, there is no addition of color happens when we add copper metal into the zinc sulphate solution. Now, by this what we means is that zinc, now by this what we understand, what we conclude is zinc wants to remain in plus 2 oxidation state. Zinc wants to remain in positive oxidation, in positive charge, not oxidation state. Oxidation state is a term I will later introduce. Zinc wants to remain in positive charge in presence of copper, or let us say the tendency of the positive charge on zinc is more in presence of copper than on copper, means the zinc 2 plus formation is preferred over the copper 2 plus formation. Okay. Now, we have to realize ki why is it so, ki why copper 2 plus has been converted to copper, but zinc 2 plus has not been converted into zinc. This is because one of the things we define called electrochemical series. Electrochemical series. Now, what is electrochemical series? This now we have seen that one metal wants to get oxidized, one element wants to reduce. Similarly, okay, if I have taken an example of this copper and zinc, let us take another example of copper in presence of Ag plus. Okay, the 2 Ag plus. Okay. Now, we know that copper does not want to go to copper 2 plus, copper wants to stay in copper, but in presence of zinc. But in presence of Ag plus, what happens that copper goes to copper 2 plus and Ag get reduced. Okay. This is gain of 2 electrons and this is loss of 2 electrons. That means, we have seen that copper gaining electrons copper gaining electrons in presence of silver in presence of Ag plus, but not in presence of Zn2 plus. Now, this is the thing which is known as competitive electron transfer. Okay, that copper can gain electron in presence of Ag plus, but copper can't gain electrons in presence of Zn2 plus. Now, why is it so? That means copper is more reactive to gain electrons in presence of silver, but zinc is more reactive in presence of copper. There must be a series, there must be something that we should know something, that which element will get oxidized, which element want to get oxidized in presence of which element. So, there should be a series, there should be some series that which element will oxidize, which element will not oxidize. Okay. So, there has been such series that called as electrochemical series, that which element will get oxidized first, that means which element has a tendency to go into positive oxidation, positive charge first, and which element has the less tendency to go into the positive charge, or which element has the better tendency to gain electrons, or which element has a better tendency to lose electrons. This series is known as electrochemical series. This electrochemical series is a series this series also known as metal activity series, electrochemical series or metal activity series or electrochemical series. So, the two names, and what this series defines as is, this series defines why this series has been designed to know us the competition for the electrons between the various metals, that which element will gain electron and which element will not. What this electrochemical series is, means how these elements are being arranged. Till then, thank you.